from you. Javier. Or anybody else. Please, let's save time. Let's be quick in our response so we could save time, okay? Is somebody ready?
Sir, please, you should read the question.
Yes. Quickly go through.
Okay. Two particles P and Q are each positioned at a height of 100 meters above the ground. P is projected vertically upwards with a speed of 10 meters per second square.
10 meters per second.
Okay. With a speed of 10 meters per second, while Q is projected vertically downwards with the same speed.
Okay.
Calculate the time interval between the arrival of P and Q on the ground. Acceleration due to gravity is 9.8 meters per second square.
Thank you. So we have two particles, P and Q, all projected from the same height. Meanwhile, one is projected vertically upwards and the other is projected vertically downwards. Okay. Now, we are to determine the time interval between the arrival of both P and Q on the ground. The time interval. So all that we are to look out for is the time for which P drops on the ground, the time for which Q drops on the ground, and then the difference in their time. That is the whole requirement of the question. Okay. So we want to bring clarity to the question by first drawing. So let's assume this is the ground. The ground. We have from the ground to where this is P. P is projected. The height or the distance from the point to the ground is 100 meters. Then from Q, the point Q, also to the ground the same. Meanwhile, P is projected vertically upwards. So P goes up and just to a maximum height before dropping to the ground. Okay, so from here to this point, we are calling as the maximum height H max. So this is maximum height H. Now Q, which is this, is thrown vertically downwards with a speed of 10 meters per second. This is thrown vertically upwards, also with a speed of 10 meters per second. So class, all that we are to look out for is the time for which P and Q would drop on the ground, and then we determine the time interval between those two times. Please, are we okay? Are we fine?
No, please.
So all that we are to look out for is the time for which P, which is dropped vertically upwards, would go reach a maximum height and drop to the ground. And so the time for which P would go through its whole path, okay, and then drop to the ground. Then we also look at when Q is thrown vertically downwards, what time will it take to drop to the ground, okay? And then after obtaining these two different times, we look out for the difference or the time interval between the two, okay? And that is the requirement of the question. Please, are you okay? So let's consider them one at a time. So considering P. P is thrown vertically upwards. So that is going upwards. When P goes gets to that point, okay, it will take a certain time to reach the maximum height. So when we've learned about time taken to reach the maximum height itself, and so on and so forth. So we can, when P is thrown vertically upward, we can determine the time taken to reach the maximum height to be equal to U on G. Okay, meaning for P to reach the maximum height, we just would have to divide its initial velocity by gravity. So 10 divided by 9.8. And this will be 1.02 seconds. Please, are we fine? Are we fine?
Yes, please.
Okay, now when we are looking for the total time for the journey of P. So it will take this time for P to move from here to here. What about the time for which P would move from the maximum height to the ground? Okay, for which P would move from the maximum height to the ground. Now, time taken by P to move from the maximum height to the ground. Let's represent that by T1. Okay, let's take that to be T1. It also means that we need to get this height, the maximum height itself, meaning from this point to the maximum height, we have to determine the height H. And how can we find H? Class, how can we determine the maximum height raised by P? Yes, quick one. Anybody? Okay, Akosia.
U squared out of 2G.
So using U squared on 2G, we can find it. Okay, so U squared is 10. So 10 squared divided by 2 times 9.8. Okay, and that is equal to, what is 100 divided by 2 times 9.8? Quickly calculate that for me.
5.10.
Come again.
5.1.
Akusa, I didn't hear you.
5.1.
Okay, so 5.1. Okay.
0.
Okay. So it means that the maximum height H is this. What then will be the total distance from the maximum height to the ground? What will be the total distance or height, the maximum height to the ground? Yes.
100 plus 5.1.
Go. So total height becomes 100 plus 5.10, giving us 105.1 meter. So it means P moving from the maximum height to the ground will cover this total distance. This is 5.1. This is 100. Okay, so if I'm looking for the time taken for P to move from the maximum height to the ground, using H is equal to UT plus half JT squared, I can determine this value. Now H is this value 105.1. So 105.1 is now equal to, now when P is moving from the maximum height to the ground, it will be free falling. Okay, it will be free falling. So initial velocity u is equal to 0 when it has to come from the maximum height to the ground. So 105.1 would be equal to half times 9.8 times T1 squared. I label that as T1, so T1 squared. So class, quickly help me find T1. What would be the value of T1?
$4.63.
Come again.
4.63 seconds.
Okay, so T1, I'm coming, let me, T1 will be equal to 4.6.
63.
Okay, 63 seconds. Therefore, total time taken by P would be equal to the time taken to reach the maximum height, which is 1.02 plus 4.63. And this will total 5.66. Okay. Class, are we okay?
6.5.
Okay.
Yes,
Okay. All right. So this is the total time that will be taken by P, right? So let's consider Q. So considering,
Mr. Dear,
hello.
he says 5.65.
Okay. Considering the body Q, what happens? Now, for Q, it is projected downwards. Okay. So using H is equal to UT plus half JT squared. Now my problem, the information given in the question is that, hello? The problem with the information given in the question here. Lower hand. Go ahead and ask your question. Please go ahead. If you have a question, quickly do so. Oh, hello.
Mr. Dear,
All right. So my problem with the information is that once Q is given an initial velocity, its acceleration would have to be different. It shouldn't be due to gravity. So its acceleration will not be, or shouldn't be 9.8. Because if it's accelerating by that margin, then the initial velocity must be 0. But here, what the whoever set the question failed to realize is that if the body is not free falling, the value of the acceleration will not be 9.8 meter per second squared or 10. It must accelerate with a value greater than that. But they only gave us for KO, the acceleration is also 9.8 as gravity. So we have no option than to use the information as we were given in that manner. Please, class, you understand what I'm saying?
yes, please.
Good. But that's what we are given. So we cannot change it. But in actual sense, once the body is given an initial velocity downwards, it has to accelerate more than the acceleration due to gravity. Okay, so that's the observation I made. So for Q, then H, which is 100, would be 10 times T plus half by 9.8 T squared. Okay, so we have let's multiply through by 2. Divide 9.8 by 2. That is 9.8 by 2. What did we get? Okay, 4.9. So we have 4.9 T squared. Now let's equate everything to 0 so we can have a quadratic expression. So we have 4.9 T squared plus 10T minus 100 equal to 0. Okay, now you see over here we cannot have perfect roots. Okay, we cannot have real roots for this. So we use almighty formula to find the factors of T, right? So comparing this to ax squared plus bx plus c is equal to 0, we can deduce that a is equal to 4.9, b is equal to 10, then c is equal to negative 100. So we are comparing what we have to almighty, the quadratic equation formula. And that's how come we could deduce that a is equal to 4.9, b is equal to 10, c is equal to negative 100. Class, are we fine?
Yes, please. Yes, please.
Okay. Now we are going to use this almighty quadratic equation formula to solve for the value of T. And the formula to use would be T is equal to minus B plus or minus square root of B squared minus 4AC all divided by 2 times A. So this is what we are going to use to find our T value. Please, if you are writing, quickly do so because I want to direct the camera to the other side so we can use it there. So I'm giving you a minute or two to quickly write. All right?
Okay.
All right.
Stadia.
Hello.
Stadia, please. So the body kill velocity is not really important.
Velocity as in what?
The final velocity.
Oh, you can also use that. This is, yes, I understand your question. We can also use that to find T. I get your question. I'll explain. Okay, using the velocity term too. Okay.
Okay, sir.
Can I redirect the camera?
Yes, please.
Yes.
Okay.
Yes, please.
Okay, so T, a second, please. Okay, so T then will be equal to negative B is 10, so minus 10 plus or minus square root of minus 10 squared, which
Mr.
will still
Can you please adjust your camera?
what's the problem?
Please, can
What's
you
the-
adjust your camera? I can't see.
Oh, I get you. I
It's
get
okay,
you.
thank you. Go upwards a little.
I hope it's better.
Yes.
Okay, so minus 10 squared, then minus 4 times A. A is 4.9. Then C negative 100. All divided by 2 times 4.9. So negative 10 plus or minus. Please simplify all that we have within the bracket for me. Negative 10 squared will be 100. This is negative, negative. So plus, what is 4 times 4.9 times 100? Put that together and then give me the final result.
One nine 60.
119.
60.
Okay. Okay, so 1960 divided by 2 times this is 9.8, correct?
Yes, please.
Okay, so minus 10 plus or minus 100 plus 1960.
2060.
So 2060. This is 2060 divided by 9.8. Here, you see, it's a plus or minus, and we don't have anything like negative sign. So we throw away the negative and use the positive. So we have t is equal to minus 10 plus, what is the square root of 2060?
What is 5.38?
Okay, so 45.339. Okay. Therefore, T would be equal to 45.39 minus 10 divided by 9.8. So we have 35.39 divided by 9.8, which is what is 30? Which is
3.61. Sorry.
3.61 seconds. So this is TQ, the time taken by Q to drop on the ground. Please, any problem?
Mr. Dia,
Hello.
please, we're finding the T. Is it compulsory to use the quadratic formula?
You see, we are using the quadratic formula because what we have, the quadratic expression will not give us real roots. They are decimal. So whenever you have values and it will not, whatever you have will not give you real roots, especially when you check and you realize that b squared minus 4ac, okay, it's not equal to 0 or so. Then I'll confirm, but I'll confirm and give you the condition on which you cannot use the real roots, okay? But I'm trying to recall. When you check and then this is not equal to 0, then it means you have to use the almighty quadratic formula. So Akusha, that's the reason why I use that, okay?
Yes, please.
Good.
So if you're able to use the other one, Will you be marked?
Oh, yes, you will be marked correct.
Correct, okay.
Because the other one would have to give you the same results.
Yes, please.
Okay. So the time interval.
Mr. Edua.
Hello.
Mr. Edua, please. Then you wrote the formula and you substituted the b square. You wrote -10.
Yeah.
But when you were given a is equal to 4.9, b is equal to 10, you didn't add a negative sign beside it.
Come again with a question. When?
Sir, please, are we saying when you were writing a is equal to 4.9 at the other side of the board?
Yes.
B is equal to 10.
Yes.
But when you were substituting in the formula, the b square, you wrote -10. Isn't it supposed to be 10?
No. You see, the formula. Let me redirect it for you to see. I think this is the side you are talking about.
Yes, please.
When we compare, A is 4.9, B is 10, C is -100. Are you okay?
Yes, please.
Good. But the formula itself has a negative B, -B already. Okay.
Yes,
so
please.
I got a -10 because the formula already has a negative attached to the B.
Okay.
Meanwhile, B is a positive, but B it changed because of the nature of the formula.
Oh, okay. Understand now, sir.
Okay. And up here.
But Mr. Edua, in the square root